Hello students, this topic is very important for your examination. Many problems are coming into the semester exam. You can check the previous year questions as well. That is Carnot map. Okay, Carnot map, we call it as K map. It is a visual way to simplify logic expression. Okay. So far I have discussed about the Boolean algebra, the method of simplifying all the Boolean expressions. Now, if the variables number, that is the number of variables is more than 2 or more than 3, it will be quite awkward, quite time consuming to solve them and simplify them. Then we need one technique that is known as map method. And one very fine map method is this K map. Okay, that is we have in our syllabus. So it gives the most simplified form of the expression. If you are solving it with K map technique, so in Boolean algebra, whenever you are solving many Boolean expressions, it may be the case that you are simplified up to one step, your friend is not coming into that answer. But for this K map, totally simplified. It is one generalized technique. Okay. So let us start with this. What is the technique? So simplification of logic expression using Boolean algebra is awkward because it lacks specific rules to predict the most suitable next step in the simplification process. It is difficult to determine whether the simplest form has been achieved or not. Okay. So a Carnot map is a graphical method used to obtain the most simplified form of an expression in a standard form. I have already discussed with two standard forms, that is SOP and POS. The simplest form of an expression is the one that has the minimum number of terms with the least number of literals, that is variables, in each term. By simplifying an expression to the one that uses the minimum number of terms, we ensure that the function will be implemented with the minimum number of gates. Okay, I am not reading it out. I will just explain you with the example. So by simplifying an expression to the one that uses the least number of literals and each terms, we ensure. Okay, so K map is basically, many things are written here. So I should explain you that you can understand. So K map is basically a three-dimensional map. If you take a paper and it is actually foldable. It is foldable. So it is three-dimensional kind of paper you can imagine. These are the examples. So if I explain to you with these examples, it will be much more beneficial. This is the example of three variable K maps. Let us take the first expression, that is function. So it is summation. Summation means, you already know, summation means mean terms. Okay. So it is sum of product. The technique is sum of product. Summation 0, 4. So mean term 0. That is mean 0 means M0 and 4 is M4. Okay. So M0 and M4 is present here. Now don't look into this B bar C bar. We don't know that. Okay. That is the expressed one. I will explain you. So how to draw the K map? How to draw the K map? That is three variable. So I am taking A here and BC in that side. And A can be the combinations I am putting here. Okay, 0, 0, 0, 0, 0, 1. So A can be either 0 or 1. So two rows are there, 0 and 1. And B can be 0, 0, 0, 1, 1, 0, 1, 1. Right. Now, why it is written like 1, 1 first, next 1, 0? Because K map does not allow simultaneous 2-bit change. Simultaneous 2-bit from 1 it is changing to 0. Clear? So 2-bit simultaneous change is not allowed. That is why we are writing this 0 0 0 1 1 1 1 0. Okay? We will follow it further. So for 0 0 0 it is the M0. So M0 is present here. So I am writing here 1. Next 0 0 1. So it is M1. M1 is present or not? No. That means we are putting a 0 here. If it is present, then we are putting 1. If it is not present, then we are putting 0. M2 is present? No. 0. M3, see 0 1 1. That means it is M3. 0. See, if we read it like this, M0, M1, M2, M3. Okay, it is not M0, M1, M2, M3, M4, M5, M6, M7. No. We have to read it like M0, M1, M2, M3, M4, M5, M6, M7. Clear? And 0 and 4 is present. That is why I am putting here 1 and here 1. Now, the pair. So first we have to look for the bigger groups. Okay, bigger groups. If it is possible that all these points are 1, then there will be one octet. So we can make a 8-1 pair. See, but here all the values are 0. So we are making a pair. We are making a pair of 1. With this, how to determine the answer? I will come into this 4 group and 8 group as well. Okay. So this one, see, if we are going this column wise, then it is B bar C bar. Why B bar C bar? A is changing. See, row wise, A value is changing for this to 1. So whenever the values are changing, we are not taking that. So A is not taken, but we are taking it like B bar C bar. Why B bar C bar? For sum of product, I have already told you that 0 means B complement, and that is also 0, so C complement. Okay, that is why the answer will be, the simplified expression will be B complement, C complement for this example. Okay, let me explain another example. It will be much more clear to you. Function of summation 4 and 5. So whenever it is written like summation, so obviously it is sum of product. So mean terms are written here. So it is M4 and M5. So A, B, C, the same process we are following. 0 and 1. A can be 0 or 1, and B 0 0 0 1 1 1 1 0. Okay. Now in this M4 we are putting 1 and M5 we are putting another 1. The other are 0 here. Okay. So here we are making one pair and we are checking it row wise. It is A. Why A? Because the value is 1. So the original form A, and column wise B is not changing and that is B bar, but C is changing from 0 to 1. So we can't take the C. Okay. So the answer will be A, B bar. Clear? This is the process. Very simple. Next one, we have 0, 1, 4, 5. So let us take one example of 4 groups. So 0, M0 is 1, M1 is 1, this is M2, not present, that is 0, M3, not present, this is 0, M4 present, so 1, M5 present, so 1, M6 and M7 are 0. Okay. Now we can make 2 pair here, but that is of no use. Always check for the bigger group. Always check for the bigger group. So if there are 6 ones, can we group them? No. We can group in a way that is 2 to the power n formula is maintained. Okay. Whenever we have to group, we can pair them like 2 to the power 1 is 2. We can make a group of 4, 2 to the power 2 is 4. We can make a group of 8 because 2 to the power 3 is 8. So we can't group a couple of 6. Okay. So here these same. So it is B bar. C is changing, so we can't take them. And A is also changing, that is 0 to 1. So the answer will be only B bar. Clear? This is the third example. So moving forward to the next example. Okay, that is we are putting here M01, M1, M2 and M3. So here one couple of 4 is coming. Okay, we are pairing them, and this group is actually, if we see like this, A bar is the answer, because these 4, B and C is always changing. So we can't take this B and C, the answer will be A complement. Okay, this is very simple method. Next is, let us discuss this example. This is another important example, another case I can show you. So this is function of M4 and M6 in SOP. So M4 we are putting 1 into this M4, and M6 we are putting here, see it is 0, 1, 2, 3, 4, 5, 6, 7. So this is 4 and this is 6. So we are putting here 1. Now can we group them? Because they are actually there are zeros in between these two 1. But we can group them, because I told you K-map is a 3-dimensional kind of structure and we can fold them. Okay, if we think these K-map as a paper and you can fold them, then these ones are actually coming side by side and we can pair them. Okay, this is another very crucial point for pairing. So we are grouping this one and that one, and it is coming like A. The answer is, see, A, because A is in its original form, and the corresponding column wise we are checking, B is actually changing. So we are not taking B, and C is going from 0 to 0, so same. So C bar. So the answer will be A, C bar. Okay, this is the answer for summation of 4, 6. So this kind of another problem we can take this example function. It is actually in the exam this kind of problem will be given, function and summation something. It will be given in your exam. You have to solve this K-map and you are expressing this answer. So this is not given in the exam paper. This is the question only. Solve K-map for this. Solve K-map for that. Okay. So if this is the question, then 0 and 2 we are putting M01 and M21, and this is again, if we can fold, then you can group here, and this is A bar, and find this is C bar, because B is changing, no? 0 and 1, so it is changing. So the answer will be A bar, C bar. Okay. The last example I will show, that is function is given as summation 0 to 4, 6. Okay, this is the problem statement. After looking into this problem statement, we are drawing this K-map and we are putting the values, those values who are present we are giving 1, and those which are not present we are putting it as 0. And now M0, M2, M4 and M6 are 1, and actually we can group these 4 ones. Okay, side by side, if we fold, then they are grouped, and the answer will be, see, here A is changing from 0 to 1, we can't take, and here column wise B is actually 0 and 1, B is also changing. See these two, only these two you have to check, because these are zeros. You have to check only this column and that column. Okay, and from here 0, 1, so B we can't take, and C will be C bar. Okay, A is not taken, B is not taken, so C will be, the answer will be C bar. So very simple and very time effective solution, that is K-map. This is the example for 3 variables.